When we drew Lewis structures a couple of modules ago, we introduced bond order, which characterizes the number of shared pairs in a bond. We can also get bond orders from molecular orbital energy level diagrams. Bond order can be determined from this simple relationship. The bond order equals the number of bonding pairs minus the number of antibonding pairs. We count pairs of electrons because it takes a shared pair of electrons to form a bond. We'll include sigma and pi bonding and antibonding electrons. In order to get bond orders, we first have to put electrons into our energy level diagram. Let's do this for the dihydrogen molecule and then for the proposed dihelium molecule. First, H2. Each hydrogen atom has one electron in its 1s orbital. When the molecule forms, the electrons have their choice to go into the sigma bonding or sigma antibonding molecular orbital. Since systems in nature seek the lowest energy they can find, the electrons choose to populate the bonding orbital. Notice the total energy of the electrons has gone down, as you would expect when a bond forms. H2 has 2 total electrons, so it may be puzzling as to why the diagram shows 4 arrows. Remember that this is a before and after picture. The electrons in the atomic orbitals show the energy before bonding, while the electrons in the sigma bonding or molecular orbital shows the energy after bonding. We know that helium is an inert gas, but we might ask why this is so. Why doesn't He2 form? We'll use the same energy level diagram, although we put the energies lower as the helium electrons feel a greater effective nuclear charge. Each helium brings 2 electrons, so there would be 4 total electrons in the proposed molecule. As with atomic orbitals, we can only put 2 electrons in a molecular orbital. 2 electrons go down in energy into the bonding orbital, while 2 electrons go up in energy into the antibonding orbital. Notice that there is no net change to the energy of the electrons. He2 doesn't form because it is not at lower energy than the individual atoms. So what about bond order from these diagrams? We really don't need to include the electrons in the atomic orbitals in the pictures since we're focusing on the molecular orbitals. All we really need to know is that there would be 2 electrons in H2 and 4 electrons in He2. In dihydrogen, there is 1 bonding pair while there are no electrons in the antibonding orbital. The bond order is 1 minus 0, which equals 1. This is a single bond. In dihelium, there is 1 bonding pair and 1 antibonding pair. The formula gives 1 minus 1, which equals 0. A bond order of 0 means there is no bond, which is consistent with what we decided previously.